Hello. So today we're going to be going over section 6.3. Section 6.3 is going to be dealing with matrices. And I think it's going to be our last section of the semester. So that on Wednesday I can answer any last minute homework questions for your exam. And then after that, after this week, it's week 18, it's our last week of instruction. And that way, after that, I can go ahead and answer and prepare you for your final. I'll post a review for your final this weekend, so you can have a week to prepare. And then you'll have, after week 18, you'll have that whole week, well, up until Thursday to complete it. I know our final is scheduled for Monday, but in case you want to take it later on in the week, that's okay. It's just, I'll let you prioritize however your exams are going. I think for the most part, I think most instructors are like giving you the whole finals week to work on your final, but I know there might be some instructors who want to stick to their time frame and day, which is okay, but I'll give you the liberty of choosing whenever you want to turn it in, as long as it's due by Thursday of finals week. All right, so let's go ahead and continue with our new section, so 6.3. I'll go over the new section, and then after that, I'll answer any homework questions. All right, so hold on to your homework questions till after lecture. So I'm going to go ahead and share my screen. All right. So we're going to do 6.3. That's going to be matrices. This is our last section for the semester. So in case those of you that are joining us, so this Monday we're doing 6.3 on Wednesday. Mainly be like on office hours in case you have some questions for your exam 3. And then this is week 17. And then week 18, I'll focus on reviewing some main questions that'll be on your final. So Monday and Wednesday, we'll review. And then you have finals week. And I'll have the final exam available all weekend long, the weekend of week 18. And your final is due by Thursday of finals week. And I'll let it be up to you when you want to turn it in, as long as it's due by that Thursday, end of day Thursday. And that's a breakdown of what we have left. We're on week 17, then week 18, and then finals week. And that's it. 3 more weeks, or 2.5, and you're done. All right, so let's go ahead with our new section 6.3, solving linear systems using matrices. Our objectives are 1, solving linear systems of 2 equations using matrices, solving linear systems of 3 equations using matrices, and 3, recognizing inconsistent and dependent system. We're not doing that 4th one, the notation one. All right, so if 6.1 and 6.2 have not been your favorite types of methods, there's one more, and that's matrices. Your definitions read, a matrix is a rectangular array of numbers surrounded by brackets. In this section, we will learn how we can use a matrix to display and keep a system of linear equations organized while lessening the number of items that must be written. We will begin with a linear systems of 2 equations and 2 variables. So our first example reads, write the following system of linear equations in a matrix. All right, so matrix is a way of keeping track of our coefficients. You'll only work with your coefficients. Your variable will be assumed based on the position or the space that it's taking up. Your book reads, requiring that two equations be written in the form ax plus by equals c, we can consider each equation as a row in a matrix. The first number in each row will represent the coefficient x, and the second number represents the coefficient y, and the third number will be the constant on the right side of the equal sign. So if we take a look at our equation, this is how we write it in a matrix. So our coefficients for x are written vertically, followed by our coefficients for y at -5 and 2, and lastly, our constants. So without having to write down, we know that these are coefficients for x's, our y's, and equal to some number, right? So we know together they make up our coefficients. I'm sorry, our equations. And that's how we set up our matrix. Moving on, because each row in the matrix represents an equation, we often adjust our vocabulary when using a matrix and speak in terms of rows rather than equations. That being said, the entire process of solving a linear system using a matrix will rely on performing the following 3 row operations in no particular order. So something I always forget, just so we have it, that's a row, and vertically is a column. That's 2 words that I always mix up. All right, so these are our rules for working with row operations. And we can do any one of these. So we can, 1, swap rows. 3, we can multiply or divide an entire row by a non-zero constant. And lastly, we can add a multiple of one row to another row. And we're gonna do, these are our only rules. So our rules are swap, multiply, and add. That's what we're allowed to do. Or add, subtract, multiply, divide, right? These 3 operations are essentially the operations with equations that we perform during elimination, but now we refer to them as row operations. Using these row operations, we hope to reach our goal of a final matrix up to the form. And this is what you want to have. No matter what numbers you have, you want to make it so that you're left with a 1, a 0. This doesn't matter. It can be whatever is there. And then that's for my row 1. And for your row 2, you want to have a 0, a 1, and then whatever number that happens to be. This is important because we're essentially saying that x is equal to this number, and we're saying that y is equal to this number. That's what we're saying. So we can do this by having that setup. We want that 1, 0, 0, 1. That's called an identity. It's called reduced echelon form or Gauss-Jordan elimination. This is if you're a math major, if you go into linear algebra, you do this type of operations a lot. This is your identity matrix. We must understand why this is the goal. Considering the matrix, if we convert each of the rows back to equations, we will have 1x plus 0y equals a number, and 0x plus 1y equals a number, which will describe the values of x and y, just like I said earlier. Okay, so let's take a look at example 1. Solve the following system of linear equation using a matrix. Okay, so we set it up already. We're going to write it as, for my x's, I have 3 and 1. For your y's, you have -5 and 2 is equal to 7 and 6, your number, your constant. And your goal, you have to remember that your goal is to write it as 1, 0, 0, 1. And then continues on to say, we often focus on one column at a time. We will begin by concentrating on the first column where we want. So you first want to focus on getting a 0, a 1, and a 0. Okay, so if you take a look, don't we already have a 1? Yeah, we do. Great. So the only problem is that that 1 is in the wrong spot. But according to our rules, what are our rules? What are we allowed to do? We said that our rules are we're allowed to swap rows. We can multiply and divide and add and subtract. Those are our only moves for this game. Always think of math as a game. These are your rules. Those are the 3 rules. You can swap, multiply and divide, and add and subtract. Okay, well, just like before, we want to label our equations. Let's label our rows. I have row 1 and row 2. Row 2 has that 1 I want. So let's go ahead and swap it. And that's what it wants us to do. Considering the initial matrix, we can swap the rows to get 1 in the upper left corner. All right, so we did was we swapped our 1 with our 2. Okay, and we got that 1 in that spot we wanted. Now we set our sights on the 3. We want to make that a 0. Well, how can I make a 0? A blank plus 3 gets me 0. What will make it? Well, what should this number be? It needs to be a -3, right? Okay, it said that we're allowed to multiply and add. So wouldn't you say that I can take row 1 and multiply it by -3 and add it to row 2, and this will result on my new row 2. I can work with rows and change their value temporarily without changing the value as my set row. So I don't want to change this one, but I will multiply it by -3 and add so that I can make this one a 0 like we want. All right, let's do that work. So row 1, let me label my rows, row 1, row 2. Row 1 times 3 will give me -3. 1 will provide -3. Will give me 1 times -3, -3. 2 times -3, -6. And 6 times -3, -18. And we're going to add row 2. All right, row 2 is 3, -5, and 7. Our answer is 0, -11, and -18 plus 7, we get -11. Great, this is our new row 2. And we have that written right below. Swapping rows or multiplying the second row by a non-zero constant will not be helpful. Thinking the lines of elimination, we can multiply the first row by -3 and add the result to our second row to create a 0, which is what we did, and we have our work above. So we have a new row 2. It shows our work right here. So let's rewrite it. It's going to be written right below. So what we now have, my row 1, I didn't change it. I have that 1 I want. I have 1, 2, 6, and I have a new row 2. 0, -11, and -11. Cool. We're one step closer. Remember, you want to have 1, 0, 0, 1 as your first set of numbers. We have now completed my first column. And we have that written right below. We will now concentrate on the second column, where we want a 0, 1. A 0, then right below it, a 1. Okay, what can we do? Well, let's first try to make, well, it doesn't really matter, but what catches our eye is we see that dividing the second row by negative 11, right, we have here negative 11, negative 11. Isn't negative 11 divided by negative 11 1? Cool. So let's go ahead and take row 2 and divide by negative 11. That will give us that 1 we want. Negative 11 divided by negative 11 gives us 1. And then here it just so happens to give us 1. Okay, lastly, we want to make that 2 a 0. We now set our sights on the 2, which we hope to change to a 0. Thinking on the lines of elimination again, we can multiply the second row by negative 2 and add it to the first row in order to create a 0. Okay, so we're going to take our, always label your rows. We're going to take a row 2 and multiply it by a negative 2 and add it to row 1. This will produce our new row 1. And that will make it so that I have that 0, that last 0 we want. Okay, so if we do so, we have our work here, but let me write it down. I feel like it's easier to keep track. So row 2 times negative 2, we get 0 times negative 2 is 0, 1 times negative 2 is negative 2, and 1 times negative 2 is negative 2. Row 1 is 1, 2, 6. Our answer is 1, 0, 4, and we said this is our new row 1. And we have our work here. So to place our new row 1, and we're left with what we want. We have a 1, 0, 0, 1. Cool. This tells us so much. This is saying that your x is 4 and your y is 1, because there's no longer a y spot in the first row and there's no longer a x spot in our second row or equation 2. We have written the matrix in reduced row echelon form, and our ordered pair is 4, 1. Before we move on, we need a discussion on notation that can be used to shorten the description needed for every step above. This was the progression of matrices above. So here it shows you a summary of everything we did. So we started here and then we swapped our rows. We multiplied row 1 by negative 3 and added. And we divided the second row by negative 11. And we multiplied the second row by negative 2 and added to the first row. And this gave us our answer. So this says that my x is 4 and my y is 1 to give me my answer of 4, 1. Now I know this is different and I know this is super new. Are there any questions on the first example?
I got in class a little bit late, so I was trying to pick up with it, but maybe on the next one I'll get it, but because I started to understand it.
All right, so hold on to your question then and make sure you ask it if you still have it in the next example. All right, so what we have above, it takes a time to write a notation, which I did with you along the way. So here's how we write a notation. If you want to swap a row, you write a little swap sign. Then we multiply it by -3 and add it to the second row to produce a new second row. I like to write equals because I know that's what I'm resulting into, but a little arrow is fine. And I worked it out with you this way so that you can keep track of your work. I remember when I first learned matrices and how to row reduce and echelon form, it was something really confusing. And I think my problem was I forgot what my answer was, what we're working with. So I always made a point to say, hey, that's my new row 1 or my new row 2, just so I knew what I'm replacing. Because yeah, we know how to add, multiply, and divide, but we forget what we're working with, what that mini goal is for each step along the way, what it is. The one skill that must be practiced and mastered is to solve a system where the matrix is the ability to add a multiple of row to another row. It may be beneficial to begin a step involving this action by writing the unchanged row in the new matrix first. All right, let's go ahead and do example 2. And it has our work done for us. So let's go ahead and work it out. Example 2 says, solve the following system of linear equations using a matrix. All right, I'm gonna kind of hide the work on the side. Okay, before you begin, what's your goal? Don't forget your goal. We know our goal is to have 1, 0, 0, 1, and a number. The number you have for your constant doesn't matter. Okay, I'm looking at this and I need to make this a 1 and I need to make this a 0. That's our first step. All right. Well, we see that I want to make this a 1. And you have to kind of stop and think a little. And there is no one correct way to start. But we see that, hey, if I multiply row 2 by a -3, that will make this a -6. And if I add them, 7 plus -6, that will give me that one I want. Okay, so I want to do is we have it here. I want to multiply row 2 by -3, add it to my row 1, and that's going to equal my new row 1. Let's do that work. All right, row 2. Well, let me first label my rows, row 1 and row 2. All right, row 2 by -3 gives me -6. 2 times -3 is -6. 3 times -3 is -9. And 1 times -3 is -3. And we're going to add that to our row 1, which is 7, 4, and 18. And we said that's going to be our new row 1. So we get a 1. Cool, that's what we wanted. -9 plus 4 is -5. And 18 minus 3 is 15. All right, let's replace it. I now have this new row 1. Did I do something wrong? That was a -4. That way doesn't match up. All right, -9 plus -4 gives us -13. Cool. All right, so what's my goal? I have a 1. Now I want to make this a 0. Once you have that 1 done, a 0 is easy. You're going to take your row above, which is row 1, multiply it by the opposite. So if I have a +2, I'm going to multiply it by a -2 and add it. We have that outlined on your right. -2 times row 1 plus our 2 will result in your new row 2. Let's go ahead and do that work. So I'm going to multiply my row 1 by -2 so that I have 1 times -2 is -2. -13 times -2 is 26. And 15 times -2, -30. Plus my row 2, which is 2, 3, and 1. And it's going to be my new row 2. I have 0, 29, and -29. And I have that written right here in my new equation. All right, I reached my first goal. I want a 0, 1, and a 0. Now my next column, I want a 0 and a 1. How can I make that happen? Let's start off by making my 1. How can I make that a 1? Well, I can divide it by itself. 29 divided by 29 will give me 1. So let's take row 2 and divide it by 29, and I'll get my new row 2. All right, we divide by 29, we get 1s. Awesome. Once we have a 1, I can make the 1 above, the 0 above easily. If I have negative 13, can't I just multiply row 2 by 13 and add? Yeah, because that will make that number 0. So what we're going to do is multiply row 2 by 13 and add it to row 1 to get my new row 1. Let's go ahead and do the work on the side. So row 2 times 13, 0 times 13 is 0. 13 times 1 is 13. Negative 1 times 13 is negative 13. Let's add my row 1, which is 1, negative 13, and 15. We're left with 1, 0, and 2. Cool, and we said that's my new row 1. Let's replace it with my new row 1. And we have achieved what we wanted. I have 1, 0, 0, 1. I now know the answer to my variables. Remember, this is the same as your x's and this is your y's. So I have x is equal to 2 and y is equal to negative 1. So x is equal to 2 and y is equal to negative 1. Remember, our answer means that 2 lines will meet at a special coordinate point, and this coordinate point is 2, negative 1. So matrix is just another method of working through a system. So you have learned how to use substitution and elimination, and to your sleeve of tricks, you're adding matrices. All right, any questions? No. No questions? All right, so let's summarize our steps. Well, not our steps, our goals. So I want to try to color code it. 1, 0, 0, 1. Okay, your very first goal is get that 1. Then you want to get that 0. Third row, you want to get that 1. That 1 in that yellow. And lastly, you want to get that 0 above. So these are the steps you want to follow. You first want to find the 0, 1, then the 0 below, and then work with the 1 and find the 0 above. That would make it so that you can add them and not have to change the ones that you've gotten. All right, and here it just shows the steps. This is the new one? Oh, it's the same problem. Let's go ahead and do example 2. Here are a description of solving example 2, where we use division to determine 1 in the upper left corner, showing why wise choices can affect the ease in which a system can be solved using a matrix. All right. Solve the system Solve the following system of linear equations using a matrix. All right, so this is a problem we just did, right? But you can choose, or not choose, but sometimes you can be stuck in really messy situations. So here's the same problem, but as you can see, doesn't look a bit more complex. And that's based on how we went about it. So what happened here is we thought, well, if I want to make this a 1, can't I just divide it by 7? Or swap the 2 and make that a 1? And yeah, you can easily get a 1 by dividing by itself, but sometimes that creates unnecessary fractions. And just because you have fractions throughout your problem does not mean that your work is incorrect. They'll still result in the same answer. But if possible, try not to take the easy way out by just dividing by itself to get 1, at least not in the beginning. At the end, it's okay, but in the beginning, it's not the best choice. All right, let's go ahead and take a look at example 3. Solve the following system of linear equations using a matrix. So we have 2x plus 3x equals 15, and 6x minus 5x equals 13. I think there's an error. I'm pretty sure these are meant to be y's. Right, so let's change them to y's. Let's rewrite our problem. So that we have 2x plus 3y is equal to negative 15, and 6x minus 5y is equal to 13. All right, so let's write it as a matrix so that we have 2, 3, negative 5, and 6, negative 5, 13. All right, let's remember what our goal is. Our goal is to create a 1, 0, 0, 1. And the numbers, the very last numbers do not matter. All right, so let's see what we can do. Now this one, we see that, take a look at this 2 and 6. That's what we want to work with first. I want 1 and a 0. Well, finding the 1 should be ideal. I see I can easily find that 0, right? I can multiply it by a negative 3. Well, I can multiply it by a negative 3 to the row 1 and make my row 2 a 0. So let's go ahead and do that. So let's take row 1 and multiply it by negative 3 and add it to row 2 to get our new row 2. If I multiply row 1 by negative 3, I'm left with negative 6. 3 times negative 3, negative 9. And negative 5 times negative 3, 15. Add it to row 2. Row 2 is 6, negative 5, and 13. That's going to be our new row 2. So that I have 0, negative 14, and 28. That's our new row 2, and we have it written there. All right. Well, as I'm looking through this, our new goal should now make this to be a 1. And as I'm looking through it, the only way I can make it a 1 is if I divide by 2. Oh man, that would create a lot of fractions, right? So why don't we go ahead and save it for now, just so I don't deal with fractions. Okay, let's move on to our next goal is to make this a 0 and a 1. While I say to make this a 1, I can just divide by 14, and that divides easily into my next number 2. So we're going to take row 2 and divide it by negative 14. So row 2 divided by 14, negative 14, we're left with 1 and negative 2. All right, so what's our goal? We want 1, 0, 0, 1. Okay, halfway there. Lastly, we want to go ahead and make this, not lastly, we still have 2 more steps. Let's go ahead and try to create that 0. Let's do so by multiplying my row below it by the opposite, which is negative 3, and adding it. So that we have row 2 times negative 3 plus row 1, that gives a new row 1. Let's do the work. So I'm left with 0 times negative 3 gives us 0. 1 times negative 3, negative 3. And negative 2 times negative 3 gives us positive 6. Let's add that to row 1, 2, 3, negative 5. Doing so, I'm left with 2, 0, and 1. And that's going to be my new row 2, my new row 1. Let's replace it with row 1, which we have here. Almost there. Now, we avoided changing this 1 in row 1 because that would give me a fraction. By dividing by 2, I will be forced to have a fraction. So we saved it till the end. So lastly, we have to divide row 1 by 2. And then if we do so, we're left with our final part. And we have a new row 1. So we have 2 divided by 2, we get 1. 0 divided by 2, we're left with 0. And 1 divided by 2 is 1/2. We now have our answers. We have that x is equal to 1/2 and y is equal to negative 2. So this means our answer is the point 1/2 and negative 2. Notice that before the matrix had a 1 and a 0 on the first column. We chose to work on the second column since division by 14 was simple, negative 14 was simple. This example further explains the range of choices that can be taken in each step. We must always have the end goal in mind while we choose that row operation to apply each step. So in the example below, where I tried to give you some more instructions, that works, but it doesn't always work. So I guess it's not correct to say that. You really are left to your own choices and what works best. You just have to make sure you have that 1, 0, 0, 1. All right, last part. Solving linear systems of 3 equations using matrices. Using matrices can be even more efficient when solving linear systems of 3 equations. As with linear systems of 2 equations, we're allowed to do any of the 3 row operations in every step of the process. So our rules are the same. We can swap, we can multiply, and we can multiply and add. The goal of this matrix involving 3 equations is same as below, but slightly different. So we want 1, 0, 0, 0, 1, 0, and 0, 0, 1. Notice that you have a diagonal of 1s. And the rest are 0s. That will help you notice that while we are limited to 3 variables for this class, you can work and solve matrices or equations of even a higher dimension, 4 by 4, 5 by 5, as long as you have your rows of 1s, your diagonal of 1s. For sake of organization, it is often easiest to work with each column goal at one time. So if you want some direction, though really it isn't, each book is different. We will try to choose the first column as listed in red. So we first want to find 100. Okay, so let's go ahead and do an example 4. Solve the following linear systems using a matrix. At each step, the numbers in red are the targets for change. So if we write it as a matrix, we have 5, 1, 2, 9, 2, 7, 1, -2, 6, and 8, -3, and 11. We wrote it as a matrix. And now we want to focus on this first column and getting that 1, 0, 0. Now remember, you're allowed to swap, add and subtract, and multiply, add and subtract. You want to get a 1. And we see that, hey, we already have that done, right? I'll draw a little happy face because that makes me really happy. It means a lot less work. We see that row 2 has that 1. Let's number our rows. Row 2 has that 1 I want. So I see that, hey, I can just swap row 1 and row 2. All right, we have that as our first step. Swap row 1 and row 2. That gives us that one we want. Okay, now I'm forced to make the other number 0. That's easy. You know why I say that's easy? Is because you have this 1 here. I can take 1 and you multiply by the opposite number that you want. So if I have a 5, I'm going to multiply my row 1 by -5 and add it. If I have a 2, I'm going to take my row 1 and multiply it by -2 and add it. And that will allow me to get those zeros that I want. We have that written right next to us. So remember, now that you have that 1, you just multiply by the opposite. And what I mean is, if it's a positive by a negative, it's a negative by a positive. All right, I'll do the work on the side. All right, it says -5 times row 1 plus row 2 will give me my new row 2. All right, let's multiply -1 by row 1. If I do, I'm left with -5. -5 times -2, -10. -5 times -2, +10. And -3 times -5, 15. I'm going to add that to row 2, which is 5, 9, 1, 8. That's my new row 2. Let's see what my answer is. 0, boom, that's what we wanted. -10 plus 9, -1, 11, and 23. That's my new row 2. That's what we got. Great. All right, now remember, you want to make your row 3 a 0. To make that happen, you're going to multiply row 1 by -2. -2 plus 2, we get that 0 we wanted. All right, let's do that work. So we're going to take row 1 by multiply it by -2 and add it to row 3 to get our new row 3. Row 1 times -2 gives me well, my first term is -2. 2 times -2, -4. -2 times -2, +4. And -3 times -2, +6. Let's add it to row 3. 2, 7, 6, 11. Our answer is our new row 3. My answer is 0, 3, 10, and 17. That's what we have for row 3. It's written for us. Okay, we've completed our first column. Good job. We have 1, 0, 0. Our next goal is to have 0, 1, 0. 0, 1, 0. That's what we want next. Okay, now I see that I can get that 1 easily. I have a negative 1. So can't I multiply row 2 by negative 1 to make that a positive 1? Yeah. All right, so let's go ahead and divide row 2 by negative 1 or multiply by negative 1. And we're left with our new row 2. That now produces that positive 1. So we now have a positive 1. All we did was change the sign. So so something that doesn't do here is because it's written for you, you're not having to rewrite it each time, but every time you do a row operation, you have to rewrite your entire matrix. All right, next, I want to make these 0. That's easy because I have a 1. I can multiply it by a negative 2 to get my 0, and I can also multiply it by a negative 3 to get the other 0. So let's go ahead and do that work. So we have right here, negative 2 times row 2 plus row 1 will give me my new row 1. All right, so row 2 times negative 2 gives me 0, negative 2, 22, and negative 23 times negative 2 gives me positive 46. We're going to add that to row 1, which is 1, 2, negative 2, and negative 3. And my answer will be my new row 1. So I have 1, 0, 20, we have written as my new row 1. All right, also have my work for my new row 3. I'm going to take my row 2, multiply it by negative 3, and add it to row 3. So that we have 0 times 0, sorry, negative 3 times 0 is 0, 1 times negative 3 is negative 3, negative 11 times negative 3 is 33, and 23 times 3 gives me positive 69. Add it to row 3, which is 0, 3, 10, 17. We're left with 0, 0, 13, and 6, 86. I think I made a mistake because that 13 should be a 43 for row 3. I have 0, 0. That should be a 43. So we did row 2 times negative 3. That should have been a 33. That's what happened, not just a 3. Okay, so this is my new row 3. Row 3. Okay, our goal is to make this now a 0, 0, and a 1. All right, to get a 1, can I divide by 43? Yeah, 43 divided by 43 is 1. 86 divided by 43 is 2. That worked out. We have our new row 3. We have our written work right there. Okay, now that I have 1, I can easily make these zeros. I can take row 3 times 11 and row 3 times negative 20, which we have right here. All right, I'll skip the arithmetic, and we now have our answer. Remember, it's written as X, Y, and Z. So we have X is 3, y is 1, and z is 2, right? So we have x is equal to 3, y is equal to -1, and z is equal to 2. As a coordinate point, it's 3, -1, and 2. X, Y, Z. All right, example 5. Same work. Let's write down our goal. Our goal is to have 1, 0, 0, 0, 1, 0, 0, and 0, 0, 1. And then some number. The number doesn't matter. It's helpful if you first start with your column, but like we've seen before, there is no exact way every time. It's just whatever you think works best. All right, so our first goal, it's written as a matrix, and I want to be able to get a 1. How can I get a 1? Well, I don't have a 1 given, so I can't just swap them. But don't we see this 3 and this 2? What's 3 minus 2? That gives us that 1 we want, right? So we can go ahead and subtract. That's what you have written on the side. You can go ahead and say row 1 minus row 2 will give you your new row 1. What they did was multiply it as a negative, but it means the same thing. So if we subtract, what do we have? 3 minus 2 gives us 1. -7 minus -3 gives us, I think that's a mistake. Oh no, it's right. -7 minus -3. They're positive, so we get +4. Yeah, -4. We get -4. -1 minus -1, we get 0. And 5 minus 2, we get 3. Cool. We now got that one we wanted. That was our new row 1. All right, now I want to make the ones below 0. And we see that can easily be done by multiplying your row 1 by a opposite sign. So row 1 times -2. And then we're going to do row 1 times a -6. And that will help us make those zeros. Let's do the work. Let's write our rules. So we're going to take row 1 and multiply it by a -2. We're going to add it to row 2, and that's going to give you your new row 2. And that's what we have there too. Just want to rewrite it for you. So let's multiply row 1 by -2. I get -2. -4 times -2, +8. 0 times -2, 0. And 3 times -2 is -6. Let's add it to row 2. Row 2 is 2, -3, -1, and 2. Okay, we said this is going to be our new row 2. Let's find our answer. Our answer is 0, 5, -1, and -4. Cool. That's what we have for a row 2, right? And we created that 0. All right, now I want to make a 0 for the very last row, row 3. We're going to take my row 1 and multiply it by -6 and add it to row 3. That's going to give you your new row 3. Let's do our work. So row 1 times -6 is 1 times -6 is -6. -4 times -6, +24. 0 times -6 is 0. And 3 times -6 is -18. Add it to row 3, which is 6, 2, 1, and 22. So we have 0, 26, 1 and 0. Oh no, 1's negative. So we're just left with 4. And that is our new row 3. 1, 26, 0, 26, 1, and 4. So that was our row 3. And we have row 3 right here. All right. I won't go in the detail as much anymore. What's our new goal? Our new goal is to create 0, 1, 0, right? Well, how can we make that happen? Take a look at everything you have. We have -4, 0, 5, -1, -4, and 26, 1, and 4. Well, if I want to create a 1, just in general a 1, I can always swap it, right? I would be okay swapping if it's row 2 or row 3. I don't want to move row 1 where it is because it has that 1 I need. But these two are zeros. It doesn't matter if I have a 0 above or below because those two are zeros. But here, I know I can only move these two. What can I do so that I can make 1? Well, isn't 5 times 5 25? And isn't 26 1 off from 25? So I can multiply row 2 by -5 added to row 3 to make that 1. And that can be my new row 3. We have that there. And then I can just swap it. And now to make those leading zeros, it's easy because I just multiply my 1 by a +4, multiplied by 1 by a -5. It's always the opposite sign, and add. Lastly, to get your last number, you're forced to divide by what the number that it is. So because I have -31, I have to divide by a -31. Luckily, your publisher made it so that they're easy numbers, not fractions. Then it's easy to get your remaining zeros. You multiply your 1 by -6, you multiply your 1 by -24, and add. So that your order triple is 304. All right, so just like before, we have inconsistent systems and dependent systems. This is where you have answers where you're left with a number equals itself. In that case, it's infinitely many solutions. Or we have a situation where I have a number equal to something that's not itself, right? They're not equal. You can say it's a false statement. In that case, there's no solution. You'll have the same type of situation for matrices. So let me briefly walk you through an example because I know I've been talking for an hour and I'm sure it's kind of hard to keep track without a break. All right, so we're working through our problem. We want to get 1, 0. And then we're left with a situation where after doing our step, we're left with this. Is 0 equal to 19? No, right? So this would be a situation where there's no solution. Let's read our book. At this point, we're finished with the matrix. Consider the second row back as an equation. So you have 0x plus 0y equals 19. The contradiction of 0 equals 19 allows us to determine that the given system has no solution and is called an inconsistent system. Regardless of the matrix size, anytime a row in a matrix becomes all zeros except for the last number, the row is interpreted as a contradiction, and there will be no solution. So here works out a problem, and after you're working it out, you're left with the situation. You're left with all zeros. Now in this case, 0 is equal to 0. I have 0 is equal to 0. And that's true, right? So this would be infinitely many solutions. All right, that's it for this section. Let's take a look at your homework. Your homework for this section. Let's do some examples together. So let's take a look at chapter 6. 6.3. All right, 6.3 practice problems. Solve the following linear systems and matrices using matrix and 3-row operations to convert the reduced row echelon form. All right, I know you have the answers to the odd ones online, so let's go ahead and work out an even one. Let's take a look at, I don't want to do the first one. Let's take a look at 6. Let's do 6 together. So let's go ahead and work out number 6 from your 6.3 homework. If we do, we want to work with matrices. Let's write it as a matrix. As a matrix, this is 3, -6, -1, 2, and -7, 14. You know that your goal is to make 1, 0, 0, 1, and the numbers at the end do not matter. So I'll just write a little number sign. Okay, let's get to work. Now I'm gonna write a little hint. I know I want to make those a 0 and a 1. So how can, oh, backwards. So how can I make a 0 and a 1? Well, I can make a 0, right? I can make a 0 by multiplying row 1 by 2 and creating a new row, row 2. So let's go ahead and do that. I always have to write my operation. So we're going to take row 1 times 2, and we're going to add that to row 2, and my answer is going to be my new row 2. That's going to give me the 0 I want. All right, let's go ahead and do that. I have to multiply my row 1 by 2. If I multiply by 2, I'm left with 6, -2, -14. I want to add my row 2, which is -6, 2, and 14. Let's add this up. I'm left with 0, 0. Oh man, we have one of those funny situations. So this is our new row 2. Let's rewrite our matrix. So my row 1 stays. I have 3, -1, -7. My new row 2 ends up being 0, 0, 0. Remember what we said about having all zeros? So this is a statement. 0 is equal to 0. And that's a true statement. So our answer is many solutions or infinitely many solutions. That would be your answer.
So
Well, let's work out. Yes, I'm sorry.
So as long as we get one row to equal all zeros, we could stop there, and the answer will be a true statement, infinitely many solutions.
Well, okay, so yes or no. If you get all zeros, infinitely many solutions. But the trick is, you see your numbers here? We always want to have a number. In this case, we have those ones and zeros. If there is such a case where we're left with all zeros, let's say a 0 is on the top, and equals a number, that's when we can stop. If the numbers here give you zeros, that's when you know you have a situation that's different. Because remember, these are your x's and these are your y's. So if all of your x's and y's are 0, you're left with 0 equals some number. So yes, it could be where we have all zeros, but I could have had a number there too. I could have had, let's say, a 2. Then that would have given me 0 equals 2. So the moment all of your variables become 0, your variables are x and y. The moment all of your variables are 0, like we have here, that's when we can say it's a different answer, like infinitely many or no solution.
Okay.
I know this is very different. I am anticipating a lot of questions for this section. Now, it might be helpful to know that this section is not in your review. I'm stopping at 6.2. So I'm sure that's nice to hear because I know matrices are different. They are challenging. So I'm stopping at 6.2 for your exam. However, 6.3 will be on your final. But this is our last section for the semester. On Wednesday, I'm for easier when going through it on YouTube, for example. So again, all of your homework, all of our lessons are posted on YouTube. You can just search my name and you'll find them there. Every lecture, with the exception of our second lecture, that's the only lecture that for some reason didn't record. But I've since then have learned. So all of our lectures are recorded and they're posted onto YouTube. I get them on as soon as I can, but usually my husband's hogging the internet, playing online games, like play League of Legends. So that's the only time where I might delay a bit, but for sure I'll be there by tomorrow. My hopes is that they'll be there within an hour or two in case you want to look at our lecture again. All right, if there aren't any more homework problems, I'm gonna pass. Yeah, Jessica.
Sorry. Can we do 6.2 number 6?
Yeah.
Thank you.
6.2 number 6. Number 6. Dun, dun, dun. Okay. You know what's funny? As I'm looking at it, I want to do matrices just because it's just what we did. But that's not what we're doing. So for 3 variables, we're working with elimination. Okay. Your idea is to get rid of the same variable twice. I should say eliminate. Twice. Okay, I see that I don't have any x's, and I don't have one x, and I don't have one z. So getting rid or choosing to eliminate your x's or your z's would be ideal. So let's go ahead and pick one of them. I'm gonna choose x just because. Why not? So let's make it a goal to get rid of our x's. Always make it a goal to get rid of your x's in your life. All right, so this one doesn't have an x, right? So that's going to be my one of my new equations. I have 3y minus z is equal to 4. Okay, now I want to work with equation. So let's number our equations 1, 2, and 3. Now I want to work, this was equation 2. Now I want to work with equation 1 and 3 so that I can eliminate my x's or eliminate an x, and that's going to be my new equation. All right, I see I can multiply by a -1. That will give me a -3, and if I add it, that will eliminate my x. Let's go ahead and do that. So if I multiply my first equation by -3, I'm left with -3x plus 2y plus 5z. Oh, I think I changed my signs. So equals -7. So have +2, now it's a minus, +5, now it's a minus, y equals -7. I'm going to add that to equation 3. So that I have 3x.
It's 5z. It's
5z. Thank you. Z. 3x plus 17y, no z, equals 27. That's going to be our other new equation. So that we have, that's gone. That's what we wanted. -2 plus 17 is 15y plus 5z is equal to -7 plus 27. We have 20. All right, so we have our new equation.
Is it minus 5z? Is it minus
5.
5z?
Minus 5z is equal to 20. All right, so let's forget we have 3 variables for now. And let's work with this. Let's go ahead and solve for y and for z. All right, if I want to solve for z, or eliminate a z or eliminate y is catching my eye, but z will work just as well. Let's go ahead and get rid of our z's. Let's multiply by a -5. If we do, this will make it into a positive 5z, right? All right, let's do our work here. So 3 times -5 is -15y. -1 times -5 is plus 5z is equal to 4 times -5, -20. And then I have my second equation, which is 15y minus 5z is equal to 20. Right. So my y's add up to be 0, my z's add up to be 0, and my 20's add up to be 0 too. So we're left with this funny situation where 0 is equal to 0. All right. Now, you could have worked through it a bit differently, but you should get a number equals itself. You should get a true statement. Whenever you have a true statement, your answer is infinitely many solutions. And we're done. Since this is one of our special cases where we have infinitely many or no solution, we're done. So this is your work for number 6.
Thank you.
You're welcome. Any other homework questions? All right. Before we take off, Andrew, do you have anything to share?
Yeah, we'll be doing some of the review at 6:30 today in
Ooh,
class.
okay.
Yeah, so getting ready for the test that starts Wednesday, correct?
I'll
Yeah.
make it available Wednesday.
Okay, yeah, so we'll be doing that today. So yeah, come join us. And then the matrices, we'll do that next week in the sessions, but because I know that's hard, but
That's tough.
yeah, if you take your time on it, you guys will understand it. You just gotta need practice, you know.
It's practice, rewriting and rewriting. It's a lot of rewriting. That's
Yeah,
problems you're gonna want to do in a separate sheet maybe. And just being patient. Like if you need to
exactly.
take a break, you can take a break. Because after doing those, sometimes I can't even add. There's times where I've done a problem like 10 times and I'm just mad and I just leave. And I try it the next day and I'm like, what was so tough with it? It happens. Not that you'll have to do it 10 times, but
Yeah, when you get the little tiny errors, it's frustrating.
it's frustrating.
Yeah.
But you only have a problem like that on your final, and I promise I won't make it too challenging. I'll make it fair difficulty. All right. Well, that's it for today. Have a nice evening. I hope you go to our SI session so you can do really well on your exam 3. Thumbs up, Diego.
Thank you. Bye.
Thank you, Jessica, for asking a
Thank you.
question.
Bye.
Thank you,
Happy
David.
semester.
Thank you, Diego. Have a nice day. Thank you, Zachary. Thank you.